Hello everyone, this is Jahnavi, Department of ECE, working as an assistant professor in the CSE Institute of Engineering and Technology, Tadepalligudem. So now I am dealing introduction to microprocessors and microcontrollers. So in this, the definition of microprocessor is, the microprocessor is a programmable device which allows the central processing unit and to perform arithmetic and logical operations for the I/O peripherals, memory and some external devices. Now we will see the diagram of microprocessor. So here the main component is CPU. For this we are connecting input signal and it generates output. Here memory also we are connecting externally. Okay, so the examples for the microprocessor is 8085 microprocessor and 8086 microprocessor. Okay, next coming to the microcontroller. So microcontroller is a single chip. In that single chip all the components are integrated in that single chip. So we will show the diagram. So here the CPU, memory, and I/O peripherals, all the components are integrated in a single chip. Okay, so the examples for the microcontroller are 8mega 328, 828051 microcontroller are the examples for the microcontroller. Okay, now coming to the pin diagram of 8086 microcontroller. So this is the 8086 microprocessor. Okay, so this 8086 microprocessor having 40 pins. Here the ground pins, first one and 28th pin are ground pins. These ground pins are used to reduce the noise of the stability of this circuit. Okay, next AD0 to AD14 and here AD15. These pins are address lines. A stands for address lines and D stands for data lines. So the address lines and data lines gives the informations for this 8086 microprocessor. So the address lines and data lines are also called as multiplexer lines. Okay, next coming to the NMI. NMI is nothing but a non-maskable interrupt. Whenever the noise is generated, so it generates the continuity of the signal. Okay, so interrupt. Whenever we are executing the program, during the execution of the program, whenever it generates breakouts, so the interrupt will manages here. Okay, so next the clock signal. The clock signal generates the information of the pin diagram. Next coming to A16 to A19. So here, so address lines and data lines, here S3, S4, S5, S6, S7, these are all called as stack segment. So before introducing of this stack segment and address segments, we will discuss these points here. So the reset pin is used to initialize the signals of the processor and ready pin is used to start the execution of the 8086 microprocessor. The test pin also used to test the execution of the program. So and here the VCC is the supply pin. So the supply pin is used to give the supply for the 8086 microprocessor. Here the voltage of the microprocessor, so here the voltage of the supply is 5 volts and here we will talk about these address lines and stack lines. So coming to address lines and stack lines, here S3 and S4 are the stack lines and S5, S6 are. This S5 is logic 0. This S6 is used to perform flag conditions. So we have different types of flags. For example, parity flag, zero flag, interrupt flag. So different types of flags are there. So we will continue this topic flag registers in the next video. Okay. So this stack segment is used to generate the flag signals. Here the S3 and S4 performs whenever 0, 0, 0, 1, 0, 0, 0. Okay. So 0, 0 manages the all segment registers. So we have different types of segment registers called stack segment, data segment, core segment and extra segment. So these segments are generated by this 0, 0 condition and next 0, 1 condition. So here we perform function calls. function calls. Here we generate variables. And here we generate instructions here. Instructions here. So function means whenever we are storing the data of the 8086 microprocessor, the data will be transferred by using this function call. Okay, so from coming to the variables, whenever we are storing the data into the locations, so the variables are used. Here the instructions. So we have different types of instructions called as instruction, arithmetic instructions, logical instructions, string instructions. So these instructions are performed in this condition. Okay, next coming to BHE and S7. So the BHE and S7 is bus high enable unit. Whenever BHE is 0, here 0 bar, it indicates 1. Whenever BHE is 1, the logic is performed. Whenever it is 0, the logic is does not perform, it will becomes in an ideal state. So the read condition is the program will be in read state. Here we are having hold data, HLDA, and here request, grant, lock, and these pins are used for stack and queue stack. We will discuss about these topics now. Coming to these pins, 31 pin to 24th pin. Okay, here the request and grant pins are there. So in the request and response, whenever we send the request, it gives the access to the execution of the program, or else whenever we send the request, it gives the grant of this processor. Now coming to S2, S1 and S0. S2, S1 and S0. So we are having a 0 to 7 bits. Okay, in this it performs interrupt acknowledgement, and here we are having a IO read operation in the 001 condition. Here 010 condition, it performs IO write operation. In 001 condition, it performs halt operation, or here whenever we are executing the program, the execution of the program will stops here in this condition. Here it is a opcode fetch. Opcode fetch instruction will be performed, and here it is memory read and memory write operation. And here after performing the all operation, all the program in the pin diagram, it will becomes in a ideal state. And coming to the QS0 and QS1 pin is, these are used to queue instructions. Now these queue instructions are performed. So we have queues like here. So we are having queues. So these queues are up to 1 to 6 bytes of queues are performed here. Okay, so whenever we are performing the operations here, the performing operation will be stored in this queue. So it performs the FIFO operation. So FIFO operation is performed in this queue condition. So this is all about the 8086 microprocessor. And now coming to the introduction of architecture of 8086 microprocessor. So this is the architecture of 8086 microprocessor. So this 8086 microprocessor is divided into two types, which is bus interfacing unit and execution unit. In the bus interfacing unit, we are having the three types of components. Those are instruction bytes and segment registers, and we are having summation or adder here. And coming to the execution unit, we are having arithmetic and logical unit and general purpose register here, and we have operands and flags here. So we will discuss about bus interfacing unit. So the bus interfacing having instruction queue, and the 8086 architecture having bus interfacing unit and execution unit. So in this bus interfacing unit, we are having three components called as instruction bytes and segment registers and the summation here. From coming to the execution unit, we are having a general purpose register and arithmetic and logical unit and operands and flags here. Okay, now coming to the instructions, whenever we are fetching the instructions from the memory interface, this memory interface will stores the data into these queues. These queues having 6 bytes of operation, and these instruction queues are perform FIFO operation, first in first out operation. So whenever we are storing these interfacing data into the instruction queues, those are calculating by using physical interface. The physical interface formula is segment register segment register into 10H plus offset value. So again we are from the memory interface, we are fetching the data from the memory interface, and those data will be stored into the instruction queue. The instruction queue will pass the data to the segments. So before passing to the data segments, it will calculate by using a summation. So this summation will be calculated by the physical address. So the physical address formula is a segment register into 10H plus offset value. So the segment register is nothing but this segment register we are having. So here address segment, code segment, stack segment and data segment. So these are called as segment registers. So for example, we are calculating the code segment. Here the code segment value is some 2435 into 10H. So the offset value is generated between the code segment. Again, coming to the control system. So this control system is used to generate the arithmetic and logical unit. So we all know about the arithmetic and logical unit. So arithmetic and logical unit performs the addition operation, arithmetic operations and OR operation. So arithmetic operation will generate addition operation, subtraction, multiplication, division operation are generated by using this arithmetic unit. And coming to the logic unit, AND operation, push, pop, increment and decrement operation will be generated by using this logical operations. All the operations will be generated by using this arithmetic and logical unit. And coming to the AH, BH, CH and DH. So these are called as accumulator register, BH base register and count register and data register. These are called as general purpose registers. Okay, so these general purpose registers are sent to the control system, transferred to the control unit. This control unit will be fetched by using this instruction queues, and this instruction queues will be again sent to the memory interfacing unit. So here we are having operands and flags. So we will discuss at the last topic. Flags are generated, different types of flags we have. So those are interrupt flag, parity flag, zero flag. So like that different types of flags are generated here. So operands means whenever we write the code like move AL comma BL, move AX. So we are assigning for this register, we are assigning value for this register. So those values are stored in this operands. Thank you.